Hello, Math Study students. Today's lesson is all about conditional probability. We will know we are successful when we can use conditional probability with both Venn and tree diagrams, as well as tables to solve probability questions. Conditional probability is when you're given, that being the keyword, given additional information about the selection. The given data becomes the total or universe, essentially shrinking the sample space. This is especially useful for problems involving Venn diagrams or tables. We've talked about this in class before. If you are looking at, for example, the whole school of about 1,200 students, and you're trying to randomly select one student, it's going to be that one out of the 1,200. But if you're given that it's just students in my 3A math class, suddenly we've shrunk that universe to just include those 40 or so students in that class. And so our probability has changed. And we're going to look at some examples of that. There's other words that can indicate conditional probability, given being the key word. So if you see a probability question with the word given in it, you probably know that you're going to be dealing with conditional probability, in which case the denominator or the total or the sample space or universe is going to shrink, get a little bit smaller. But other words that we can see used instead of given is like if you say it is also known that, or of these people, or of these things, knowing this other information somehow indicating that. So to start with, we'll look at this example, which is going to be a Venn diagram example, which is one of the things we wanted to get to in our learning intentions. We have 30 students. They were asked about their favorite topping for toast. Again, favorite spelled using the English, the British English, as opposed to American English, which is what IB uses. 18 like peanut butter, 10 like jam, and 6 didn't like either one of those. We're going to make a Venn diagram to show this information in part A. So we start off with our universe. Our universe is going to be the whole group of 30 students, so I can indicate that there. Now I've got my peanut butter, which is group A, and I know that that group contains 18 students total. And then I've got my jam group, which is group B, and that's going to be 10. Then I know that I had 6 who liked neither, so they'd be outside of that group. Now I'm trying to find the probability, the number of students who like both peanut butter and jam. Well, before I can do that, I probably need to fill in those 3 little sections, the blue crescent, the American football shape in the center, and then the black crescent on the right side. So what I can do is I can call this like X, Y, and Z, or lowercase a, b, and c, and make up some algebraic equations. I know that little a plus b plus c plus the 6 who didn't like anything, they should all add up to 30. That's a lot of variables, so I need some other equations. If I look at the blue 18, I know that the blue 18 just contains the little a and the little b. So if I add up the a plus the b, I should be able to get 18 from that. And I could make up some other equations, but I think this is going to be enough for us because we know already that a plus b is equal to 18. And if I go back to my original equation, I had an a plus b there, which again is going to be 18. So I can rewrite that as 18 plus c plus 6 equals 30. If I combine like terms with the 6 and the 18, I get 24 plus c equals 30. If I subtract 24 from both sides, I end up with c equals, and sorry I couldn't keep my line straight, I'm out of room, would equal 6. So c equals 6. So I go over here, c is 6. Now I know that the whole circle will be, that black circle is 10, and if part of it is 6, the other part would have to be 4. So the 4 and the 6 here add up to be 10. And then group A, which is 18 students in the blue, I already know 4 of them are in there in the center, and so 18 minus 4 would leave me with 14 students left, or you could say 14 plus these 4 here add up to be the 18 in that group. And then if I add up all these sections, the 14 plus the 4 plus the 6 plus the other 6 that didn't like either, that adds up to the whole universe of 30. So it says find the probability, or part B says find the number of students the number of students who liked both peanut butter and jam. Well, a number is not a probability. It's just the actual amount. And right there in the center, we see that there were 4 students. So the number is 4 who like both peanut butter and jam. And last but not least, part C, find the probability that a randomly chosen student from the group likes peanut butter given that they like jam. So we start with the word given. Whatever is given is now the whole universe that I'm looking at. I'm no longer looking at all 30 students. I'm only looking at what I was given. And I was given that they like jam. So who likes jam? Well, that's group B. And there were 10 students in group B. So right away, I can write down my universe or my total, which is going to be 10. So I'm only looking at 10 students. I can cover up, the 6 over here and the 14 over here. Don't even look at those. Only look at the 10 students in the black circle who liked jam, because that's what I was given. Now, of those who I was given, those 10 students, which ones like peanut butter? Well, those would be, again, only looking at those 10, that would be the 4 in the center who liked peanut butter. So my probability is 4 out of 10. And that would be conditional probability. Let's do another example like that, this time with a table. A survey was carried out with a group of 200 people. They were asked whether or not they smoke. The collected information was organized in the following table. So this is an example of experimental probability like we did at the very beginning of this chapter. One person from this group is chosen at random. Write down the probability that this person is a smoker. Well, if I look at all the people who are smokers, I've got the 60, whoops, lost my board there for a second. There we go. Sorry about that. So if I look at all the people who are smokers, I'm looking at 60 plus 30, which is a total of 90 people. And it said there were a total of 200 people. So the probability this person, this random person, is a smoker is 90 out of 200. Part B, write down the probability that this person is a male given that they are a smoker. Well, I see the word given. What was I given? I was given that they're a smoker. Again, find the word given and see what you were given. We were given only smokers. How many smokers were there? There were 90. So that's my new universe right there. 90 people total. Now, of those 90, I want to know the probability the person is male. So I look at these 90 here again, and there were 60 males out of the 90. That reduces to 2/3, but you can leave it this way. 60 over 90 is my conditional probability. Again, it's conditional because we had that extra condition that we were only looking at smokers, which shrunk my total or my universe or my denominator down to 90. Now it says find the probability that the person is a smoker or is a male. And this is a good review from our first test. Erase what I've got going here. And smoker or a male. So this person is a smoker or a male. In fact, they're a smoker and a male. This person is a male, which is a male or a smoker. And this person, or these group of people, is they are smokers. So I've got this whole column here, which is all smokers, and this whole row here, which is all males. And if I add up all of those, 40 plus 60 plus the 30, that gives me 130. There was no given this time. There was no conditional probability, so it's all going to be out of 200. Okay, so that works well for tables and Venn diagrams. You can just sort of limit your totals or limit your universe when you have a conditional probability given. But sometimes we're dealing with formulas, or sometimes we're dealing with tree diagrams, and we can't just shrink down our universe because it's not quite as easy as that. So this is a formula that we can use. It's read A, that vertical line that I just pointed to is given. So A given B. It's a shorthand, just like the plus sign we don't read as, cross symbol, we read as plus. Or minus, we don't read as dash, we read as minus. We know what it means. And so, again, right here, that's A given B is used to represent that A occurs knowing that B has already happened or B is already defined. As it mentions here, this formula is especially useful for tree diagrams or if you have no diagram at all. And the formula says the probability of A given that B has occurred, so two different things, A given that B has occurred is equal to the probability of A and B divided by the probability of B. A better way to write this would probably be probability of A and B divided by the probability of B. And that is conditional probability, A given B. Not A divided by B. A given B is equal to the probability of A and B divided by the probability of B. Let's try that out in a problem. For this one, we are only going to do questions 1 and 2. You're welcome to do 3 on your own. We've got a bin A, which contains 3 red and 2 white tickets. And then we've got bin B, which contains 4 red and 1 white ticket. A die with 4 faces marked A, 4 faces marked A, and 2 faces marked B is rolled and used to select bin A or B. A ticket is then selected from this bin, determine the probability that, number 1, the ticket is red. So we first should probably make a tree diagram. So what actions do we have happening here? Well, first and foremost, we're going to roll a die and determine which bin. So we roll the die to determine it's either bin A or it's bin B. Then from there, we are going to select one ticket. And so our ticket could either be red or white. And that's true for both of our bins, red or white. Now let's fill in some probabilities. It says the die has 4 faces marked with an A. So that's 4 for A, and B has 2 faces, so the grand total of 6 faces on the die, so 4 out of 6 and 2 out of 6. Now when we get bin A, we said up above, I circled in red that there were 3 red and 2 white tickets. So that's a total of 5 tickets. 3 red out of 5 or 2 out of 5. And then for bin B, we had 4 red and 1 white. So 4 and 1, again, total of 5 tickets. So at this point, my tree diagram is totally set up. What we're going to do next is this first question. Just find the probability the ticket's red. As I look at this, I see there's 2 ways to get a red ticket. I can get it this way or this way. In order to get there, I first have to roll the die. And so my first red, I would follow this path. 4 6 times 3 fifths. 4 times 3 is 12. 6 times 5 gives me 30. So 12 30ths to get that red. Or if I want the other red, I follow the path again. And I would do 2 6 times 4 fifths, which gives me 8 over 30. If I add those together, 8 plus 12 gives me 20. So I have 20 over 30. Question number 2, which is the last one I'm going to do here. Now it says the ticket was chosen from B given that it's red. Given that it's red. Now you can think about what this means, and that's a very helpful thing to do. So we already know the ticket's red. So you had a red ticket. What's the probability that it came from bin B? Even if you don't totally understand the problem, we're going to use this formula that I just showed, which is the probability of A given B is equal to the probability of A and B divided by the probability of B. Whatever is, that's our given symbol. So whatever comes after that, that's what was given. So the formula says we were given B. Well, in our actual question, it says given that it's red. So I'm going to rewrite this. Anywhere I used to have a B, I'm now going to replace it with red because that's what was actually given to me, given that it's red. So the probability of something given red is equal to the probability of something and red, all divided by the probability of red. Now what goes in place of my somethings? I got to go back. So given that it's red, what's the probability that it was chosen from B now? So our actual formula is going to be the probability of B given that it came from, that it was a red ticket. So anywhere I used to have an A is now a B. See, the first step really is to write down that formula and then change the variables so they're correct. Again, I wasn't given B in this case. I was given red. And I'm not finding the probability of A, I'm finding the probability that the ticket was B. Now that I've got this set up, I'm just going to throw in some numbers. So I got the probability that it came from bin B, given that it's a red ticket, is equal to the probability that it was from bin B and red. So let's look on our tree diagram for anywhere where we have B and red. And that would be this probability right here, 8 over 30. So that's my numerator, 8 over 30. Now it's going to be this double-decker fraction, and the denominator is just the probability of red. Well, we did that in part 1. Probability of red was 20 over 30. So I'm going to put the 20 over 30 there. Now, some of us who are good at double-decker fractions, you may notice that something's going to cancel out here, which will make this problem easier. Otherwise, if you're dividing two fractions, remember, you can turn it into a multiplication problem. I'm going to bring my work up over here. And so I've got 8 over 30. And I'm going to turn that into a multiplication by multiplying the reciprocal, 30 over 20. Again, you can always multiply the reciprocal, and that's the same thing as dividing. And now you'll notice that we have a 30 in both the numerator and the denominator, which just leaves us with 8 on the top, 20 on the bottom. So the probability is 8/20, which also can reduce down to 2/5. And that's conditional probability. And once again, notice that the denominator got a little bit smaller. We're not looking at the whole set. We're only looking at those that dealt with red tickets. All right. This can get a little bit challenging here. On the homework, we've got page 291, 1, 3, 8, 10 through 12. Next class, we will take a test on probability diagrams. And what I mean by that is we'll have Venn diagrams and tree diagrams and things like that. No conditional probability on that test, but by doing this homework, you'll be reviewing your tree diagrams and you'll be reviewing your Venn diagrams to help you out with the test. Good luck, and we'll see you next class.